Our topic for today is using addition with probability. You can see with our learning goals that we have probabilities of mutually exclusive events and probabilities of inclusive events. So it'd probably be wise to start with some definitions. And here they are. Inclusive events. Events that occur at the same time. For example, a student could belong to two different clubs at the same time. But mutually exclusive events, events that cannot occur at the same time. An example of this would be like flipping a coin, can't get a head and a tail on the same toss. Rolling a die, can't get a 2 and a 5 on the same roll. So we're just talking about things that can happen at the same time and things that can't. It would probably be a good idea going forward to be observant of what kind of activities, exclusive or mutually exclusive or inclusive, that we're talking about. So in our first example, we have a little survey done here. It says, find the probability that a randomly selected respondent to the survey is satisfied with or has no opinion about their long-distance service. So you can see up on top, we actually have the formula we're going to be using. And that formula tells us that if we take two mutually exclusive events, they have nothing to do with each other, we should take the probability of the first one and add it to the probability of the second one. So the probability of A or B happening in mutually exclusive events is merely an addition of the two probabilities individually. So here we go. If we look at this situation, let's spell out some of the numbers that we're going to need. Find the probability that a randomly selected respondent to the survey is satisfied with their. If we look at our chart here, satisfied means we have 245 that are satisfied over our total of 500. If we talked about the people who had no opinion on their long-distance service, then we'd be talking about the 45 again with the total of 500. So those are the numbers we're going to have to use if we write this. Now, what are we really looking for? If we write each probability separately, we would have a setup that looks like this. Probability of the satisfieds plus the probability of the no opinions. Now, take the satisfied numbers that we outlined, write them in terms of a probability, and add them to the numbers for the no opinion. Common denominators are there, so just add them up. You have a fraction in lowest terms. If you don't, then you can always write it in percentage form as well. And you'll see some of them written in fraction form and some of them will be in percentage. So you'll see it both ways. Next, if we talk about inclusive events, on this case, our long-distance carrier, it seems find the probability that a randomly selected respondent to the survey is a customer of the long-distance carrier B, so we want them to be in B, or is satisfied with their long-distance service. So right now, you got to be thinking anybody who's in B. Okay, so that would again be 200. Anybody who's in B, that would be 255 people or 250 people out of the 500. So just the probability of being a B carrier versus the second choice, or is satisfied with their long distance. Now this is an example where you could belong to both at once. Now satisfied with their long distance, again came from 245 out of that 500 number. Okay, so there will be obviously some overlap because you can be a B and you can be satisfied, but you could have been the A and been satisfied. So let's go through the math here. The setup, probability of B or S, but then we have to take care of those values that are really part of both. So the probability of B, which was being a B carrier, being in B, 250 over the 500. The probability of S, which is you're satisfied with your long distance service. If you're satisfied with your long distance service, that was 245 over 500. But then we have to subtract the ones that are B's that are also satisfied, which I believe were 180. So again, looking at our numbers, probability of B, that was our 250 over 500. The probability of being satisfied, that was the 245 over 500. And now subtract the 180 over the 500 that were B but satisfied, and that was still out of the 500 people. And so that should be our result. We have common denominators again, so do the math. We should end up with about 63% of our customers were in this. I am a B member and satisfied. Okay? So the big deal to remember here in our mutually exclusive situation, or last one was mutually exclusive, this one is inclusive, so we're talking about inclusive, when you are inclusive, this is the formula. We take the probability of the first, the probability of the second, and we have to subtract basically that overlap. Where do the two situations overlap? The ones that would have been counted twice, think of it that way. And that's what we're doing with that formula. So there's our inclusive formula. Another vocabulary in probability is the idea of complement. So a quick definition, the complement of A consists of all outcomes that are not in A. So if we say, I want all of them that are red versus all of them that are not red, that's what we're talking about here. So if I have this shape, our sample space, and I know the probability of A is in the circle, all the things that would be not A would be everything in our sample space that is not in the circle. In other words, in this case, the light blue area. So think of these three statements, and they're all legitimate. You can use any one of them as an idea to set up your formula. So if you know that you have the probability of A plus the probability of its complement, it has to equal your whole space 100%, which is 1. If you know you have your probability of A happening, you also know that it's 1 minus its complement is equivalent to it. So the whole space minus the complement part is left. And also, if you know the probability of your complement, then that means 1 minus the probability of the A factor is also equivalent to probability of A's complement. So notice the notation and how we do that. And the complement, again, consists of all outcomes that are not in whatever is desired. So with that, you will be able to find some probabilities, and you will probably use that and be asked about that in your work today. So bring any questions you might have to class, and we should be good to go.